So yesterday I presented to you two of the Fantastic Four, which were the fact and the question. And I also said that the answer to the question would be our hypothesis. So today I'll start by showing you the other two of the Fantastic Four, okay? So beginning, we have our hypothesis. And as I said, it is the answer to the question. But if you remember, I also showed to you a definition of the hypothesis. So to fit this into this framework that had four steps, I would say that the hypothesis is a plausible answer to the question, and also it has to provide causal explanations when the answer is provided. Okay, so it is important to notice that the answer had to be plausible, but this does not mean that it has to be correct. These are different things. Okay, so when you think about an answer to a scientific question, it has to make sense, but you may discuss if it is the right answer or not only after seeing your results. Okay, so please keep in mind this important difference. um, I used these two steps yesterday, so I will use the same fact: the two individuals of the spring-tailed species touching their heads and performing this push and retreat movement. And I will also use the same question, that is, why do they perform this movement? Okay, so if I have to fit a hypothesis here, I think that a first answer that I would provide would be something like this, that it is a mating behavior. Okay, so they perform this movement because they are mating, they are performing behaviors to mate. But there is a small problem here, because although it may be a plausible answer to this question, it does not provide explicit causal explanations. I don't know if you can see this. So I work with sexual selection, so I have a natural tendency to think about hypotheses that involve sexual selection, okay? And I will change this hypothesis. But also remember that what I'm providing here, that it is a mating behavior, most classes that I teach the structure, it is the information that people provide when they are describing the fact. So the interpretation that was on the fact yesterday actually should be our hypothesis here. So I would just change it to a more statement that have more causal explanations. Okay, so I change to this. So I may state, for example, that why do they perform this? It can be males that are signaling their condition to improve their mating chances. Okay. When I say in this form, I change the hypothesis, the prior hypothesis a little bit, but I can identify the A and B part. Okay. Mating chances are the A part, are our response variable here, and males signaling their condition is the B part, actually the causal explanation here. Okay, so remember that when you have a question, you may think of more than one answer. There's no problem in doing this, and each answer should be your hypothesis, and it has to contain causal explanations. Okay, um, so until now, looking from yesterday and today, if you have to build a study, a project, a manuscript, you will go through three steps. Oh, this is difficult to say in English, but you will go through three steps, okay? And I love to go through these steps, but this does not mean that they are very easy to be performed, okay? Because they need that we spend a lot of time thinking if the fact is in reality a fact, if the question is simple, is objective, is answerable, and if the hypothesis is a plausible answer to this. So you have to go to step one, which I think that has some suffering, like this one. You have to identify a fact. After that, you have to formulate a question, okay? And after that, you have the third part, which is postulate a hypothesis, okay? So no suffering, imagine, at all. And when I ask students, the next step, basically after providing a hypothesis, how can they evaluate this hypothesis? They just think, oh my God, I had to think, I had to thought about fact, question, hypothesis, and I also need to think, how can I evaluate it? And this is the face expressions that I often see on them. This one. Because we need a further step. It is difficult to imagine how can I evaluate my hypothesis just thinking on the hypothesis. And that's where the fourth step will be fitted, that is the prediction, okay? So if I could define a prediction, I would say that it is an experimental result or an expected pattern. If you are doing an observational study, there's no problem. It could be an experimental result or an expected pattern, an expected situation that should occur if the hypothesis is true. Remember that. If your hypothesis is true, if it is the more probable answer that explain the fact, you would expect some specific results, some specific observations, and these are the predictions that you can make about your hypothesis, okay? But you should think about them before collecting your data. So, for example, by using the same hypothesis, males are signaling their condition to improve their mating chances, I may expect, for example, create this prediction that spermatophore absorption, just to explain, in that video from yesterday, in the final part, the major individual, which is the female, it walked through a small liquid that was released by the other individual, which is the male. So it was the spermatophore, and the male was transferring then to the female. And the female may choose if she wants to absorb it or not, okay? So this is my surrogate of mating. If the female absorbed the spermatophore, I may be confident that a mating had occurred, okay? So I may state that spermatophore absorption by females should occur only after the male, perform the push and retreat movements. So if this hypothesis is true, if the male has to perform the push and retreat movement to signal its condition, females should mate, or I should observe spermatophore absorption only after the male had performed this push and retreat behavior, okay? But this is not the only prediction that I'm able to do about this hypothesis. For example, I can make a second one, like this, that spermatophore absorption by females should occur when males push females for longer distance. In the sense, it is my prediction is that males in better condition should be able to push females for longer distance, and this will increase the chance that I will see a spermatophore absorption, okay? And again, if you could do more than one prediction and there is no upper limit in the number of predictions that you could imagine for hypothesis, but if you could do more than one prediction for hypothesis, this has many advantages, okay? Because remember that the prediction refers to the expected result. And if you have more than one prediction, this will mean that you will have more than one line of evidence that may give or not give support to your hypothesis, okay? So if you have, for example, 3 predictions and you find the 3 predictions, you have 3 different lines of evidence that provide support to your hypothesis. So most readers, most reviewers will probably agree with you that the hypothesis you provided should, in fact, answer the question that you have made in your study. On the other hand, if you have, for example, again, three predictions and one or two of them are not found, are not found, this means that your original hypothesis, at least in the way it was formulated, is not true, okay? Because there is something that should occur that is not occurring. So your hypothesis should be, it is unable to respond, to explain the fact that you first identified. So whenever possible, I strongly recommend you to derive more than one prediction in your studies, okay? Because you have many different advantages by using it. Uh, but an associated issue when I explain hypotheses and predictions is how people could differentiate hypotheses from predictions, okay? Because it is not so, at least in the first impression, uh, it seems to be not so easy to differ them, but I hope I will be able to show you that actually it is easy. Okay, if I could draw um, a manuscript, if I could provide a draw on a figure representing a study or research article, I would start with this inverted triangle, okay? That basically represents the introduction of most articles. And by doing this, I'm saying that the article has have what I'm calling theoretical universe. Basically, it's the place in which you use to show to the readers, to the reviewers, um, where, in terms of scientific knowledge, your study is fitted. The information from your species could help understand what kind of processes. So this is the theoretical universe. I will go back to this later when I talk to theory, okay? But this is the intention of the first part. It is a theoretical universe. It is where you develop your ideas, okay? Your ideas mainly about processes. And then we have the second part. Oh, sorry, theory often plays the theory and the hypothesis. And then we have the second part, which is the empirical universe. It is where you place your experiments, your results, your data, okay? So it is the part in which you provide all the data that you gathered in that specific study. However, because the study has these two universes, the theoretical one, which is mainly focused on ideas, on processes, on things that are more general, and you also have to provide your data that is specific to your species, to your model species, to your system that you are studying, they are not so easy to be connected. Actually, you need to develop a connection between the theoretical part and the empirical part. And for me, this is where the prediction should be placed. Okay, it is a kind of connection between the theoretical aspect of your study and the empirical aspect. And you will see that in some studies, people divide variables into theoretical and operational variables. And I intend to show you that theoretical variables, as the name says, is tightly linked to the theory and should be placed in your hypothesis, and operational variables, which is more linked to your results and your data, should be linked to your predictions. So what is each type of variable, okay? In a general way, theoretical variables, they should contain information that is more general. What I mean by general is that it should be applicable for different model species, in fact, for many different model species, but at the same time, such variables are not directly measurable, okay? We cannot directly measure a theoretical variable. When I think about an operational variable, it is a little different because an operational variable should contain information that is particular to the model, to the species that I intend to study. It can be replicated in some species, but it is not its main purpose. But for this reason, it is measurable, okay? So when I use a theoretical variable, I'm more interested in providing general information. And when I'm using an operational variable, I'm more interested in measuring or estimating the theoretical variable in my study. Two frequently used examples: size and mating, okay? When I think about size, this is a variable. It is an information about an organism, about an individual, about material, okay? And I can think of many different species, many different individuals that have different sizes. So it is general. I can think of this information, this variable, for many different contexts. The same occurs for mating. If a species has sexual reproduction, I can think that males and females may be mating, okay? But to estimate both size and mating, I need to use some type of measurement. For example, if I'm studying a bird species, I can estimate size by measuring the distance between the insertion of the wing on the body to the tip of the wing, okay? This length could be used to estimate measure, and therefore it is an operational variable. Mating, for example, if I'm studying dancelfly species, I'll probably use this specific behavior. Oh, just use this here. This specific behavior in which this is the male, the blue one, the green one is the female, and they have this position which male touched or grabs the female at this part, and the female curves her abdomen to find the male penis. So they have a genital contact. So I will state that there is a mating if I see this specific behavior that is called tandem, okay? But again, if I change the species, the way I estimate the same theoretical variables may change. For example, if I'm studying trees, I may estimate size by measuring trunk circumference. I think this is the expression. And if I'm studying, for example, a fish species, I may estimate mating when I see males and females releasing eggs and sperm. Okay, so operational variables are tightly linked to our system, to our model study, to our model species, while theoretical variables, you can imagine them, they are general, but they are not directly measurable, okay? In part, this is why some researchers, some philosophers always say that you can never directly test your hypothesis because basically your hypothesis contains theoretical variables. You test your predictions, and by finding or do not finding your predictions, you may have support or do not have support to your hypothesis. Okay, and this is a very, very important distinction about what is my hypothesis and what should be my prediction. And just two tips before opening for questions that I think may be very helpful, at least they were helpful for me, is that when you think about hypotheses, we may have two main groups of hypotheses, okay? We may have bidirectional hypothesis and we may have directional hypothesis. And what is the difference? When I provide a bidirectional hypothesis, I'm saying things like this one. A is affected by or related to B. This means, for example, that I can make a prediction that as, for example, the mass of B increases, the number of individuals of A should decrease. This would be a prediction from this, but also this would accept that as the mass of B increases, the number of individuals of A should also increase. So when I say this type of relationship, they are just related, but I do not provide the direction. I can make different, I have to make actually predictions in two directions, both increasing and decreasing, okay? So this is a bidirectional hypothesis and you may use it, there's no problem. Directional hypotheses, on the other hand, have a specific direction. For example, you may have a hypothesis as this one: A is negatively affected by or related to B, or you may have A is positively affected by or related to B. These two hypotheses are directional hypotheses because if I use the first one, my prediction necessarily should provide a negative relationship, okay? And on the second one, I have to provide a positive relationship. And another related tip is if you do not have a theoretical expectation that convince you that should be used to provide direction, you should use bidirectional hypothesis. Imagine, for example, there is a theory that is still in development, that is very new. We do not know many processes. We are doing our first investigations and we do not have a specific expectation. So you should use bidirectional hypothesis. However, in many instances, we have theoretical expectations. We discuss processes, known processes that should provide a direction, okay? Because the theory also provided it to us. So if you have this, you should use directional hypothesis. And in some cases, you may have two competing explanations. For example, you may have process one that leads to the first hypothesis: A is negatively related to B. You may have an alternative process that leads to the opposite pattern: A is positively related to B. If you have both processes, you should present them and you should present both hypotheses, but in a separate fashion. Hypothesis A, and if this, or alternatively, hypothesis, the second hypothesis, okay? This is highly recommended, actually, because this is related to one thing called strong inference. I will talk just a little bit about it, but present both directional hypotheses separated. Do not mix them in a bidirectional one, okay? Because this may mix the processes that we already wanted to separate. And please avoid treating your directional hypothesis as if they were predictions from bidirectional ones. I saw some articles doing that. They have a main hypothesis that was provided in a bidirectional way. And after that, the people just provide two different hypotheses, still using theoretical variables, providing one way and the other way. So if you do this, you will skip the prediction. You will probably use just one hypothesis for each situation, and you won't be able to have many different lines of evidence. This is not recommended, okay? And the second tip is regarding the predictions. And remember that predictions have clear metric units. It could be meters, it could be seconds, counts, individuals, okay? But by doing prediction, you should be able to identify what is your smallest unit that you should count in some way or measure. And whenever possible, you do. This is not mandatory to present in the introduction, but when you are thinking about your predictions, if you have the chance, I highly recommend you to draw a figure that should be based on your prediction, because this will be very important to find eventual logical inconsistencies in your predictions and to plan your experiment and observation. For example, I have this prediction here, was my prediction 2, that spermatophore absorption by females should occur when males push females for longer distance. And I could draw this prediction in this way. I should place spermatophore absorption on the y-axis, okay, because it is my response variable. And basically, in my experiment, I would be able to see if it occurred or not, here, no or yes. and I would measure the pushing distance, for example, in millimeters, okay? So if I have this figure and this prediction is true, I should be able to find this pattern, okay? And this would be very helpful for you to identify possible inconsistencies in your predictions and to see how you could measure, you could perform your observations, okay? Okay, just a small break to see if we have some questions. Let me see. Oh, good morning, many places here is afternoon. Ellen Pasternak is saying if anyone knows a citation for the difference between theoretical and operational variables. Ellen, I know citations, but mostly are in Portuguese, okay? On the reference that I provided yesterday, and you could see them in the ABS website, there is one article that use it, okay? The first author is Gonçalves, his citation name. From Yoon Jung, so how many predictions do you think it's the most appropriate? If there is an answer for this. Yeah. Sometimes we can have more than 5 because we have various data set, but sometimes not all predictions are supported and make it difficult to interpret. Yes, very, very good question. First of all, there is no established number of predictions that you should use, okay? You see studies that use just one, studies that use 2. There is a lot of variation. Many years ago, I was interested in finding, see if there was a pattern in this number, and I started to search the number of predictions that were provided in some articles. And my impression, I did not analyze any data, but my impression is that articles published in very important journals, they often have 3 or more predictions, okay? And but there is the second challenge, that if you make a lot of predictions, you may have a result that sometimes it's difficult to interpret because you have some predictions in one way, some predictions in another way, okay? My first point here is, if you have, when you are thinking about your predictions, you should be secure that this prediction should be found if your hypothesis is true, okay? Because sometimes you have a prediction that's not directly linked to your hypothesis, and when you do not find it, you just question if this prediction was good or not, okay? This may occur, but try to avoid this. But thinking or imagine that your predictions are all direct predictions from a hypothesis, if you do not find at least one prediction, this means that your hypothesis in its original form as it was written is false, okay? You may come up with a second hypothesis that is similar to the first one, that has some derivation from it, but in essence, this is a different hypothesis, and you should treat this as this one. You should present it in the discussion, okay? And I particularly like when I have many predictions, because this gives me more tools to develop my discussion. So this is the consequence. When you have more predictions, you increase the chance to not find one or more of them, but this will often improve your ability to think about mechanisms that you present in your discussion. Let's see. Oh, thank you, Andrea, for providing the reference list. From Cesar, so are theoretical variables more like a working definition for a particular variable in the study? Cesar or Caesar, sorry, in Brazil it would be Cesar. Actually, it's the opposite, okay? Because operational variables should be a working definition of a theoretical variable in a particular study, okay? The theoretical variable is the more general one. it is more tied linked to the theory. And the operational variable should be the working definition, the way you estimate the theoretical variable. Another question from Isaac. At the time of writing the hypothesis, it is necessary to write the theoretical context of why I proposed that hypothesis. Isaac, I will ask you to wait just a few minutes because in some slides, I don't remember exactly how many slides, I will discuss exactly about the theoretical context. The short answer is yes, but I will explain it with more details, okay? Okay, any more questions? In case there's no more questions in the chat, I will keep going with the presentation. And again, you just post your questions and I'll read them at the end, okay? It could be about the things that I show up to this point. There's no problem. Let's get back. Here, let's just... Okay. So, help me slide, please. Okay. Here. So, yesterday I showed you this face because most students make this face when I explain the importance of fact and of question. And when I show the hypothesis and prediction, I often see the same type of face, okay? Because many of them ask me if there are real examples of people applying this structure in their studies, okay? And the answer again is yes, there is researchers that apply this in their researchers, and it is very, very clear when they do this, okay? So I searched for some articles in Web of Science. I came up with this one that was published in 2020. And the authors here were interested in investigating whether some species of a spider genus, if these species were able to make a mimicry of mutated wasps, okay? Specifically, they were investigating this relationship. They have some species of this genus, Paupimanus, and they were thinking that because individuals of this species are able to perform stridulation, oh, this is very difficult to say in English, I hope you understood, but because individuals of this species perform stridulation and also mutated wasps, which are predators and very poisonous individuals, also perform stridulation, they thought that individuals of this spider species would mimicry individuals of mutated wasps, okay? So what I did here was to read the introduction of this article, and I cut some parts and just pasted it here to show you the 4 steps that I presented to you since yesterday, okay? And you will probably recognize that many articles in behavior ecology, animal behavior, they have at least one paragraph in which they provide information or basic information, the natural history of the species that is being studied, okay? And often the facts are provided in this paragraph. For example, when they were describing these spiders, they said this, that Paupimanus spiders, like Mutilides, mutated wasps, are also known to stridulate when threatened, okay? And note that they cite an article that have shown this. In the same paragraph, they also say that all ages and both sexes stridulate when disturbed. And again, they cite the article that have shown this. And after the citation, they put a suggestion, okay, which is not a fact, and they clearly stated this because they wrote, suggesting stridulation may be used to deter predators, okay? So in this part, we have the facts that they used to build this study. After this, they also presented a question. In this part, they wrote, recently, we have shown that the stridulation of Paupimanus reduces cannibalism among conspecifics. Again, there was a citation, but whether or not it has an interspecific role has yet to be determined. This is very important because this is actually the question that they want to answer, because they want to know if this stridulation has some specific interspecific role. So although it is in an indirect form, this is the question in this study. And often this is the way researchers present their questions. You actually, I rarely find questions in its direct form in most articles. After this, they clearly presented their hypothesis, and I think this is very important because I saw some discussions that the authors should, I agree with that part, because they should have some freedom to choose how they write their articles, okay? But some people opt to present the hypothesis uh, in an implicitly way, and I confess that I do not like very much, because when you do not explicitly provide your hypothesis, when you do not use things such as we hypothesize it or this is our hypothesis, um, you may open the possibility that the reader will do not understand what is your hypothesis. But by doing this, we hypothesize it. All readers will understand that this is the hypothesis they use it in this study. Okay, so I like it very much. So we hypothesize that Paupimanus spiders use stridulation to deter predators, and that the success of these strategies is due to mimicry of co-occurring and highly defended motilid wasps. So this is the hypothesis, and they also presented predictions. Also note that they have a clear causal explanation of this hypothesis, okay? And they provided three predictions, okay? The first one, they predicted that there is a model, which is that there is a motilid wasps that is being mimicked by spiders, whereby both the structural characteristics, which is the operationalization of stridulation, they use it, of Paupimanus stridulation, and the mode by which the stridulation prevents precapture resemble those used by co-occurring motilid wasps. They have a second prediction that there are shared receivers that perceive the stridulation across both auditory and, I don't know how to say this, tactile channels. And the third one, that receivers exert selection on the mimic. So spiders that produce sound would have greater survival than those that do not. And again, this is important. For example, by reading the third prediction, I can see that they compared spiders that produced sound and spiders that did not produce sound. Probably they did an experiment to this. So by presenting the predictions, I understand how they try to evaluate their hypothesis, and also some of the experiments they will probably do in this study. Okay, so they follow it, explicitly follow these four steps: the fact, the question, the hypothesis, and the prediction. So just to remember you, up to this point, we have the Fantastic Four, okay? And for me, this is a much better Fantastic Four than the one from yesterday. And we also know up to this point that the Fantastic Four can be arranged in an introduction, okay? So we are able to insert each one of these parts in our introduction. And for this reason, some of you may be thinking, so I'll be able to write my introduction before collecting my data if I think about this, okay? And in fact, many people ask me if they should do this They should think about these 4 steps: fact, question, hypothesis, and prediction. Or just think about the introduction, for example, before collecting the data. And both the short and the longer answer to this is yes, you should do this. Yes, yes. Please do not forget this. You should think about the processes. You should you should create your hypothesis and think about your predictions before collecting your data, before performing your study, be in the field, in the lab, in the place you think it is necessary to do the study. Okay? Um, Basically, again, by doing this, many people think that they always need to think and to present a hypothesis in the introduction. And this is not exactly the case. Actually, you may think, you may place your hypothesis in 2 moments. You may think about your hypothesis before collecting your data, okay, this option here. And if you think about your hypothesis before beginning your observations and experiment, you should present your hypothesis in the introduction of your manuscript, okay? But there are many instances of people that collect the data. They also have a prior hypothesis, there's no problem. But after collecting the data, they created a new hypothesis, okay? So if you do this, if you think about a hypothesis after seeing your results, you should present it in the discussion of your manuscript, okay? Because by doing this, the reader will know that you thought about this hypothesis after seeing your result, okay? The thing that you should always avoid is to think about a hypothesis after seeing your results, but present it in the introduction as if it was your first hypothesis, okay? Please do not do this. Avoid this at any cost. And I'll explain many problems related to it, okay? But why I'm saying this? When I explain the situation, most people think, okay, I understood, and it is easy. If I have a hypothesis before getting my data, I should present it in introduction. If I have hypothesis before, after collecting my data, I should present in the discussion. Easy, I can do this. But you should think about two, uh, two situations, okay? The first one is the real scientific method, because at least for me, this is the way science works. I'm just hanging out, I'm just thinking about the fact and the question, and I finally gather a hypothesis. Okay, this hypothesis is very, very good. I think it is able to explain my fact. I'm very happy with it. Then I go through the data, get the data, and the data make this to me. Just know your hypothesis does not make sense. And this is my final phase. Okay, every study that I do works in this way. Okay, and you will see that it's natural that you do not become very happy when this occurs, with some exceptions. Okay, these occur basically because you spend a lot of time identifying a fact, okay? A lot of time. Believe me, this is not so easy as I explained it here in just a few minutes. You will spend a lot of time formulating a question, see if it is directly related to the fact, if it is simple, if it is objective, and if it is answerable. And you also spend a lot of time reading to think and to create a hypothesis and to formulate predictions, okay? This is a time demanding task, and you have to think a lot when you do this. So basically, when you finally get your hypothesis and your prediction, I can assure you that your relationship with them would be this one, okay? Basically, this is you, and this is your hypothesis and your predictions. So you will love your hypothesis. There's no other way, because we suffer to get the hypothesis. And because you love your hypothesis, it was your idea. Although you are aware of the problems that I have said here, you will have difficulties to reject it. This is the main problem, okay? And actually, there is a term which is cognitive bias that is often studied in psychology, and it is known for many decades now. Uh, that basically it is a variety of processes that may lead to inaccurate judgments or interpretations. So there is a lot of different processes that may be uh, that is considered cognitive bias, but I will show two of them that occur. This is common to humans, okay? So if it is common to humans, it is common for us that do science. And two that are very important for us. The first one is called confirmation bias, okay? It is defined in this way: seeking or interpreting evidence in ways that are partial to existing beliefs, expectations, or hypotheses in hand. And the second one, which is selective perception, that is the tendency not to notice and more quickly forget stimuli that cause emotional discomfort and contradict our prior beliefs. Now think, you spend a lot of time, a lot of reading, thinking about hypotheses. You like your hypothesis, okay? But then your data say that your hypothesis is not true, it should be rejected. So this is an unconscious process, but you will tend, and every of us will have the same tendency to interpret some data in ways that are partial, that tend to corroborate our hypothesis. And again, because data that do not provide support to our hypothesis cause emotional discomfort for us. So cognitive bias is a problem that we should be always aware of. And when we have to reject our hypothesis, it is not so easy as we may think here when we are just discussing this point, okay? And I could draw this. If you have this structure, you have this manuscript, you have the theory, you have your original hypothesis, you have the experimentation, you have the results, you had a lot of effort to do it, and you see that your results do not provide support to predictions, your face will be this one, okay? It is very rare that people do not do this, because it always happens to me, okay? And when this occurs, the devil is always nearby, and it will whispers in your ear, oh, change your hypothesis. Present it as if it was your original ones, and you will be tempted to do this thing, to change your text. And instead of presenting your original hypothesis, you will present an accommodated hypothesis, a hypothesis that was adjusted to your results, okay? If you are tempted to do this, please remember this. Do not do this. Wrong, very wrong. You should not present your hypothesis after seeing the result, which was changed to accommodate your results as if it was your original ones, okay? Present it in the discussion. Basically, this is associated to a problem that is called a lack of reproducibility, okay? Because if you do this, and for example, it was an spurious correlation of you just missed some point, most people will try to replicate your study, even if it is with another species, and they won't be able to find the same conclusions, okay? And this is a very important problem. So avoid this, okay? And again, I think we should have a pause to questions. Let me stop here. Let me see the one from Isaac. Thank you, Sarah. Okay, people, any question up to this point? Let me see the time. Oh, yeah, we have time. No, it's okay. Everything's clear. Thanks. Yeah, I never find support to my hypothesis. And when I was in undergrad student, in the undergrad course, I thought by reading articles that people should find support for the hypothesis because most articles reported that they always found support for their hypothesis, and I never found that. So I was very unhappy when this occurred for me on the first, the second, third time, and after this, I started to understand that this would be the norm actually. Uh, a question from Julia, I think. Do you have any comments about other fields and how they differ in thinking about hypothesis predictions? My feeling is that in psychology, differentiation is not often made. Julia, I cannot answer this question actually because uh, certainly there will be a lot of variation because these occur even in other related fields. Okay. When you think about behavior ecology, for example, and people that work with community ecology, we may find some differences. So this may change according to different fields. Okay, this is very specific to to behavior ecology, perhaps to ecology. Okay. Again, I'll keep going with the presentation. And if you have another questions, please just let me know, send it in the chat, please. Because as I said, I think that this part is not so easy to understand, okay? When I just first learned it, I had many difficulties to understand the difference between hypothesis and predictions. So if you're having some difficulty, please post your questions, okay? Let me go back to the presentation. Here, every time. Okay. I don't remember the next slide. Okay. And based on what I just have shown to you, this was a kind of what is called questionable research practices. Okay. There are more than three, but I will show you what I think are the three most discussed in our field, which I named the big old boys. Okay. And questionable research practices are actually attitudes that researchers may adopt that should reduce the reproducibility, that should cause the lack of reproducibility, okay? And they are named here as p-hacking, HARKing, and cherry picking. I think that most of you already heard something about them, but in a very synthetic way, p-hacking represents activities involving data manipulation. Basically, it is related to the statistical analysis part of each article and involving some kind of manipulation that may increase the chance to obtain significant results. For example, I think that one of the most common examples is when you have, for example, a p-value that is 0.053, you just round your p-value to 0.05, which is a correct rounding, but this will provide the impression that you have found a significant result, for example. This is a type of p-hacking. Another one that is very, very common. When you have outlier values in your analysis, okay, and they change your result. For example, when you have the outlier value in your analysis, you obtain a non-significant result, but if you remove this value, you obtain a significant result. So in some instances, people may just remove the outlier value, present the result, but do not inform the reader that this was done. So this will be p-hacking, okay? If you have a situation in which you have the outlier value, you evaluate what happens with and without it, and you provide both results to the reviewer, it's okay, because the reader, because the reader will know that you have these two scenarios. But in most instances, people just remove the value and do not tell anything to the reader. So it is another example of p-hacking, okay? HARKing is the initial, comprise the initials of hypothesizing after results are known, which is basically the example that I just gave to you, okay? When you create a hypothesis after seeing a result, but present as if it was your original hypothesis. And again, the reader won't be able to know that. And the last one, which is cherry picking, is when you fail to report non-significant results because in fact, some journals, some reviewers, they do not like very much non-significant results, and you may have more difficult to publish your article and some people may avoid it. So these three activities, these three questionable research practices, they will increase this problem, which is the lack of reproducibility. And so you should avoid it a lot. Again, when I say this in this course, most people say, okay, people, obviously, most researchers are avoiding this. And I'm not so sure because we have cognitive bias, okay? For example, I found this article, it was published in 2018, if I'm correct. And what they did actually is very interesting. They searched for articles published in 19 journals, and they searched for journals in ecology and evolution. And I highlighted evolution here because behavior ecology studies or animal behavior studies were categorized as evolution, okay? Um, and after this, they sent interview to the authors of these articles. Okay, they sent more than 3,000 interviews, but obtained 807 response answers. Okay, and they showed some interesting and at the same time worrying results. For example, they quantified the number of authors that answered that they did HARKing at least one time in the articles. So here we have the percentage of positive answers, okay, the number of authors that provided positive answers. And here we have the two classifications, ecology and evolution journals, okay? And they found that around 50% of authors reported that they used the adopted HARKing, okay? And this means that probably half of the articles that I read, the hypothesis that is presented was not the original hypothesis. They are just presenting an accommodated hypothesis. And there is obviously the results will provide support to this hypothesis, but this may be completely false. That's the point, okay? For cherry picking, the situation is worse. Again, the same information, percentage of positive answers for ecology and evolution, and they found that around 60% of authors stated that they used at least one, they adopted cherry picking, they removed non-significant results because these results were increasing the difficulty to publish an article, okay? And oh my God, non-significant results are very, very important to provide scientific advice. I will go back to this point later, but it's impressive that 6% of authors did that. And I agree, it's difficult, okay? When I have articles that are completely filled with non-significant results, and I have many of them, I have much more difficult to publish an article, okay? And the last one, they also quantified p-hacking. I'm providing just for a specific attitude, which is the exclusion of data points after first checking the impact of statistical significance. Basically, these were situations in which the authors removed the outlier because they were they were directing the test to a non-significant result, okay? Again, percentage of positive answers, ecology and evolution, and you see that almost 30%, between
Paulo.
20 and 30% of authors
Sorry,
report.
Paulo.
The slides aren't advancing.
Yeah,
Sorry?
the slides aren't advancing.
The slides are advancing?
Are not advancing.
Oh, sorry.
You have the graph, but nothing is on it.
Okay.
I think it froze because the pointer is not moving. Yeah.
Okay, I'll just start to show it again. Just a minute. Sorry, I was thrown up from Zoom. Now I'm back. Just let me try again. Let me try here. And now can you see my slide?
Yes, the
Yes.
questionable research practices.
Okay, let me just try to change. Are you seeing the change?
Keep going. Yeah.
Okay.
It's working.
Okay, just let me just hide this one.
You can cover those again because I think that's when it stopped.
It stopped in the first one.
Yeah, HARKing.
So in HARKing, these were the percentages. Around 50% of researchers have reported that they did HARKing, okay? And that's a problem. It means that almost half the articles that we are reading may contain hypotheses that were created before seeing the results, but we don't know this. For cherry picking, that was the result. Around 6% of authors stating that they did cherry picking. And for p-hacking, specifically for exclusion of outliers, we have around 20-30% of authors stating that they did this, okay? For p-hacking, the percentage is smaller than the other two because they divided the p-hacking in many different attitudes. But if we sum up these attitudes, the percentage is also very, very high, okay? So again, this means that to publish an article, we may we science in the wrong way. And this is a big problem, okay? Because if we want to provide explanations for different phenomena, we are doing false explanations, okay? I hope you are able to see this because this is very worrying, okay? And also, there is a lot of scientists, a lot of researchers that have worries about this, and we have some initiative to reduce this type of bias. The first one, I did not provide a slide for this, but you will see some studies, and I provide that in my reference, that say that you should use multiple hypotheses or perform what is called strong inference, that by evaluating different and possibly contrasting hypotheses, you will reduce the chance that you love a given hypothesis. And this is highly recommended, okay? Although in some cases it is not possible to do, but if you can, you should do. But there is another type of initiative that's being more discussed nowadays, which is the pre-registration, okay? The pre-registration is basically when you archive your study details and design, and by saying details, I mean that you should archive the Fantastic Four, you should archive your introduction and your methods, okay? Everything before collecting the data. So you archive this, you have a registration for creating this part before collecting the data, and after collecting your data, you just complement this information, okay? And a variation of the pre-registration is the registered report that is very similar to the pre-registration. But in a registered report, a journal may show an interest to your study. And basically, they may show an interest to your hypothesis, to the processes you want to investigate, and to your methods. So when you archive your introduction, your methods, it may go to a review. So the journal may send it to a reviewer, and if it is received positive comments, you may receive an in principle acceptance. So after this, you collect your data, and then you present the final product, the final article now with results and discussion. And basically, the editor will compare the first idea with the final one, and if there is, and if they are matched, you will probably have the article published, accepted, even though you have only non-significant results, because this in principle acceptance is not related to the necessity to obtain significant results. And I think this is a great idea. I like it very much, okay? I searched for some sites, websites that accept the pre-registration and the registered report, and I found two. I think that there may be more, but these are the two that I found. The Center for Open Science, which accepts pre-registration, and also this one, which is called As Predicted, okay? So if you have interest in doing this, I highly recommend that you use these options, because they are very, very good alternatives to avoid you to do, even unconsciously, attitudes that should be avoided, okay? And remember, if the data does not provide support to your hypothesis, you should reject your hypothesis, okay? In many instances, I see students, researchers, graduation students, when they do not find support to their hypothesis, they tend to criticize their methods, which is strange, because they spend a lot of time thinking about the best way to collect their data, and instead of rejecting their hypothesis, they start to criticize their own experiments. And this sometimes appears in the discussion, and it is the wrong way to do science, because if you just criticize your experiments, your discussion is just a great criticism to your experiments. If I'm reading it, my first question would be why I'm still reading this manuscript, because we know every method has its own limitations. But again, there are things that you may conclude counting with these limitations. So whenever you spend a lot of time thinking about the Fantastic Four, and if you spend a lot of time planning your observations, your experiment, and you have reliable data, and it does not provide support to your hypothesis, reject it, because by rejecting your hypothesis, you'll be providing scientific advance. And this is very important, because when you have a non-significant result, you may discuss, for example, the implications related to a non-existence, related to the non-existence of a given process, okay? You may discuss alternative explanations that now can be discussed because you remove it, the first one. You remove it, for example, a more simple explanation. Now you can explore more complex ones. So scientific advance can be achieved with both significant and non-significant results, okay? And I can show this to you. I brought a very small example of non-significant results that I think provided scientific advance, okay? This article was published in 2009, okay? And in this article, these authors were interested in evaluating secondary sexual characters or secondary sexual traits of these frog species. So these are the males, okay, these blue individuals here. I don't remember the color of the females, sorry, but they were imagining that because males are blue, this could be indicating some male traits. Though, so they postulated the hypothesis that bluer males would have larger sperm stores. Okay, so this would be an indication of how much sperm the male is able to produce and should be positively affect to male reproductive success. So they collected the males, they estimated the blue levels of each male, they measured male gonads, and they did not find anything. Okay, so bluer males did not have larger sperm stores. And often this is the time that we start crying. But they discussed many possibilities. For example, why the blue coloration evolves in this species. Okay, if the female, if for example, this affect male interaction, if this affect female choice, but not exactly female sperm store. But most importantly, 4 years later, in 2013, these authors, these researchers published this article here. It was a meta-analysis, okay, in which they evaluated basically the same question. They have the hypothesis that males that have more conspicuous secondary sexual characters would also have a higher ejaculate quality, okay? And they have 4 different estimators of ejaculate quality here. One of them was the sperm volume. And by using a great number of articles to perform this meta-analysis, include the last article that I just presented to you, they also did not find any relationship. So probably I would be crying here again. But remember, if this relationship does not exist, I may think about possible theoretical implications. For example, since I did not find this relationship, I may discuss that the probability of a general trade-off between pre and post-copulatory investment should be low, because there are some studies that suggest that there is a trade-off between pre and post-copulatory investment. And these studies show that this is highly improbable, okay? Again, the authors discussed, for example, that male secondary sexual traits, if they are not related to male investment in ejaculation sperm, perhaps these traits should be favored because they affect the way females choose males. Specifically, they recommended that other studies should investigate if male secondary sexual traits bias paternity may cause a bias in paternity but generated by female choice. Okay, so we may explore different processes, we may explore different hypotheses, and this is scientific advance. This is also scientific advance. Okay, so by providing non-significant results, we are contributing to developing knowledge. Okay, and keep this in mind, because do not try just to throw up your non-significant results. And again, I'd like to see if you have some questions. Let me see here. Oh, now we have. Okay, the first question is from Susan. Could HARKing be avoided if more predictions were made or were written better? Susan, I'm not sure if HARKing could be avoided by this way, because there is an author that published an article on Science. I forgot the first name, but the citation name is Lipton. And he discussed one thing that he called accommodation. I don't know how to pronounce this in English. And he suggested after seeing all of your results, you would probably do some adjustments in your hypothesis so that it could fit every prediction that you have. So it may not be very easy, but we are very imaginative creatures, so we may be able to do this. Perhaps it will require more effort to provide, to produce HARKing, but you may come up with a very complex hypothesis, okay? This hypothesis probably won't be the first hypothesis that a person would think, but you may try to present it in the introduction. So it may be more difficult, but if you really want to do HARKing, you may be able to do it, okay? Now from Patrick. If non-significant results are so important, then why do editors and journals reject the majority of them over articles that provide significant results? Oh my God. Patrick, very good question. And I have the same question. Okay, if you think for some reason, and perhaps it is related to our cognitive bias, people like more when results are in accordance to the hypothesis the author presented. For somehow it means that, yeah, Eureka, you discovered a thing, okay? It's more like the sensation. So my impression is that it is a subjective decision, because somehow people like when they see significant results, okay? And fortunately, there is a growing discussion among researchers, among editors, that we should look more carefully on the non-significant results. I'm just trying to read the mind of authors, of editors and reviewers, okay? But on the other side, remember that in many instances, at least here in Brazil, where I have more experience, when we find non-significant results, the way we build our discussion may increase the probability that the article will not be accepted. Because if we do a discussion that only criticizes our methods, we'll be unable to publish the article. Every reviewer will reject the article. So remember that if you have non-significant results, you should be able to emphasize why these results are interesting, what type of events they could provide, and this is important. You should present this in your discussion, okay? I think that this will increase a lot the chance that you will have a non-significant result published. For example, I tried this 2 times, and I succeeded in getting the article accepted because I focused on the good part, on the advances that non-significant results may help in provide. Okay, I hope I was able to answer that.
That helped a lot. Thank you.
You're welcome. From Jimena now, I was told that showing 2 different conclusions from the same data set based on a p-value that changed because of an outlier is confusing. Yeah, they told me I had to choose one result, either with or without the outlier. And if I delete the outlier, just inform it in the methods. Is it p-hacking? Jimena, I think that it depends. Okay, I saw this discussion other times, that people do not like when you have a result that may change according to some data. But if you tell this in your article, I strongly recommend that you show your data, or you show the results with the outlier in the supplementary material. So the reader will have access to what could happen if you keep the outlier. So this will increase the transparency of your article, and they will know that your interpretation, the discussion is based on a data set in which the outlier was removed. So by being more transparent, you will certainly reduce the problems. You reduce the chance of your committing p-hacking, okay? Just be honest to the reader. I think that is a comment to Ricky, to Patrick, not to me. I think this may part of the issue. Yeah, Rick just answered the question from Patrick, from things that increase cherry picking, and I agree. Frank Castelli just answering Jimena. Someone say you should decide how to multipliers. Yeah. Again, based on the response from Frank, for example, he thinks that some would say you should decide on how to handle outliers before you see whether including or excluding them change the results. You may have biological reason to exclude a drop that animal on its head, or in a statistical rule you decide to use in advance. I agree. Whenever you decide to remove an outlier, you should have a very good reason to do this. For example, check your data, see if you did not recorded the data in a wrong way, okay? But again, if you remove, and if the data is correct and you decide to remove, the reader must know why you decided to remove the data. This is very important. Let me see, from Gaurav. To address some of the questions in the chat, from what I've heard and researched on my own time, a lot of journals have been incorporating pre-registration, pre-registered reports, in which the hypothesis and predictions of your study are specified in a separate, time-saved, yes, an editable document before the collection of data. It is generally agreed upon by the co-authors, and some journals have been actually accepting these papers in a two-stage approach, where the first stage involves journals accepting the methodological statistical approach by guaranteeing that paper will be published regardless of the results during the second stage of publication. Exactly. This is the idea of the pre-registered report, okay? Sarah just asked if a registered report is common among journals. I talked to some researchers that I leading initiatives in this strategy, and they said to me that there is some resistance, actually. So some editors just love the idea, while some editors don't want to participate in this strategy, okay? But I think that is very premature to state that there is a great or small adoption of this. Okay, people just commenting. Okay, from Janera Kelly, would it be considered p-hacking if removing outliers supports your objective, for example, when determining normals or reference ranges? Janeta, this is the problem. If you remove the data, because by removing them, it provides support to your prediction, to your hypothesis, and you do not inform to the reader that you remove it, and the reason that led you to remove this would be considered p-hacking, okay? So if you do this, you should inform the reader the reason that led you to do this, and provide the data that was removed in some supplementary file, in some repository, so they may have access to this, okay? From Franco, he's asking, in which behavioral journals can we find these options? I think that it depends on the website you decide to use, okay? You should investigate each journal because they will provide this information. Enrique, Jimena again, but it is just they are chatting. Okay, from Sarah, how would you handle situations in which you rejected your hypothesis but found interesting patterns within your results? The new paper requires additional statistical testing that wasn't part of the original plan. Very, very, very interesting. Sarah, if you find very interesting patterns after analyzing your data, I recommend you to present them in the discussion. I will give a personal example, okay? I have a student that is investigating whether males of potential fly species, whether the color of the male affect male mating success. If males that are more colorful in some aspect would have higher mating chances, okay? And we worked with two species, and for one of them there was no relationship, but the other one showed an opposite pattern. So males that were more colorful, that they were more, I don't know the English, the word in English, they were more brighter, probably. They were rejected by females. Females preferred to mate with two males. Okay, so this is very intriguing, because most of the theory state that brighter males, that more colorful, conspicuous males, should have higher mating chance. Okay, so when we were thinking about possibilities, okay, this manuscript we just submitted for publication, it is not published yet, but when we were thinking about possible explanations, the one that we thought was that perhaps this second species, in the second species, males that are more colorful should be more probable to be found by predators. So females may avoid these males because predators may find these males more easily, okay? And this is important because when they are mating, they do not fly very well. So we made a new analysis in which we evaluated whether female males that were more brighter in the male visual systems were also more brighter to bird visual systems, which are the main predators. And we found a correlation. So we present this in the discussion. So we presented our rationale, and then we said, because we had this data, but it was not thought in the first place, we made an additional analysis and placed the additional analysis in the supplementary material, not to avoid explaining all the analysis, the methods, but present it in the discussion. Okay, so you may do this. So some research, I saw this occurring in other research papers. Okay. Is anyone here? Am I alone?
No, we're still here.
Oh, I cannot see anybody anymore, and the Zoom is not appearing to me.
We're still here.
Yeah. Oh, what is happening? I can hear you.
You can or cannot?
I can.
Okay, good.
But my window just do not open.
It might be in a small window somewhere in your desktop.
Yeah, I'm searching for it. I can see it, but
You minimize like a small window, just
let me try it here. I'm seeing the window, but it's completely black and I cannot see any options in the Zoom anymore. Okay, I'll try to reconnect. Okay, just hang on a few seconds. Okay, now I'm back. I can see you, all of you again. Um, I thought you were hearing me, right?
Yes.
Yes, yes.
Yep.
Okay. But unfortunately, I lost all of the questions in the chat. So if there is a question that I did not reply, please post it here because I lost all of them.
I think, I don't know, I think somebody had a question along the lines, and so do I, in which negative results or non-significant results are important and can push forward research. However, if you think about animal behavior or behavioral ecology, they rarely publish that, if anything, right? So, for example, you were putting the example of the moor frog, and it was published in Amphibia Reptilia, which is a perfectly fine journal. However, is too taxonomically oriented. So when you think about people like me, which we are transitioning into trying to get a tenure track job here in the US, I don't know about everybody else, but I get the message that having taxonomically oriented too many of those is not a good thing, and that we should aim for the behavioral ecology, animal behavior ones. So therefore you face a conundrum in which you do know that non-significant results are important and they are telling you something and they are moving the needle in terms of the research you're doing, yet those quote unquote don't count, right? So you see that there's not only the ethical, like, yes, we should publish negative results, they are important. However, if you want to get a job, you better stay away from publishing that or trying to publish that. I don't know if
Yeah,
anybody else has the same situation.
yeah, I totally agree with you. And actually, this is one of the most pointed reason for why people do some attitudes, why they may do hacking, why they may do cherry picking and so on. But that's why those initiatives that I have shown to you are so important because, for example, uh, animal behavior would probably the journal would probably be adopting these initiatives. Uh, if they accept your article before you get the results, you won't have any problem in publishing it just because you got non-significant results. That's why such initiatives are so important, because I totally agree with you. It is much more difficult to publish in high impact journals when you have non-significant results. And this is a culture that we need to stop. But I understand if we are not in a given career stage that publication is very important, we face these difficulties. Okay, and that's the reason why people do be hacking, cherry picking. That's one of the most important reasons. Okay, but try this. Perhaps by making a registered report, you will increase the chances of publishing an article with non-significant results. And in fact, it seems that the number of non-significant results are increasing in articles that had passed through this strategy. Okay. Um, let me see. There was a question by Ricky. I have perhaps a silly question. I do this all the time. Don't worry. How long is the process for accepting the methods design I studied through peer review? Would I be able to submit it and then start the experiment? I really like the idea of doing a registered report, but if I submit and then have to then wait 6 months before starting my experiment, that might make this much less practical for me and other trainees. Rick, I totally agree with you. This has to be a faster review, okay? But again, remember that you can also make a pre-registration. By making a pre-registration, you do not need to wait for review, okay? But in case they just spend a lot of time, you have to collect your data, you will keep collecting your data. And this will be somewhat registered during the processes, okay? From Maria Pitor, it is together, but if during your experiments you realize that you can better measure hypothesis or another more accurate variable, is this considered HARKing? Maria, here is the difference between hypothesis and prediction again, okay? If when you are collecting your data and you imagine that there is a better prediction, you still don't know what is happening, you still don't know all of your results, and you adjust your experiment, you improve the measure. My impression is that this is not HARKing because you are not changing your hypothesis. You are just adjusting the way you collect data to test your predictions. The hypothesis is the same, okay? So for me, this is not HARKing in any way because the hypothesis, your original hypothesis are still your original hypothesis, okay? From manage, as to perform, oh, this is just a chat, you're alone. Okay. Again, if you have any more questions, just post it. Oh my God, now I just lost the time, but you may send your questions, okay? Just go back to my presentation. I hope you do not have any additional problems. Oh, sorry, I'm not the host anymore. Some of was considered the host after when I quit Zoom, and the people that is the host now should give the host job, the host role to me again, but I don't know who it is.
Liliana Vasileva is the host.
Okay, Liliana, could you provide me the host role again? You have this option in your Zoom.
I can try. Okay. I'm sorry, I'm not seeing it. Do you know how to do it? Because I don't see it in on my screen.
On the screen, in the bottom line, there is no options.
There are a lot of options, but I don't see the option for host. I see security, participants, booth.
Liliana, if you go to the participants, then probably you will see Paulo's name, and then there would be like option of making him host.
Okay, let me try.
On my name, you just click on the 3 points. Did you find me?
Yeah, I'm in the list, but too many participants. Yeah, okay. And now, so I find your name, and
Yeah,
then you said,
yeah, is my cam is on. You can see me probably on your screen, and when you went with the mouse above my screen,
yeah,
you see the mute option, and on the side of the mute, 3 points. Just click on this
I
3
have
points.
more options, okay. And then
And there is an option, make host.
make a host, okay, thanks. Yeah. Thanks a lot for your help.
Now I'm the host. Thank you.
Sorry.
Okay, I went just, we'll show the presentation now, here. Okay. Moving on. In many instances, when I have these discussions of scientific advance, of what of things that you may be able to discuss when you have your results, even if they are significant or non-significant. One question that I often hear is this one: if the scientific advance should be restricted to the model organisms in my case study. And again, I think that the short answer is no. And this is also related to the point that I talked a lot of times in this workshop, but I present more formally here, which is the theory, okay? So when we think about a theory, again, I tried to find the definition, and I found this one. It is a framework or system of concepts and propositions that provides causal explanations of phenomena within a particular domain, okay? So basically, a theory, it takes a lot of concepts, a lot of propositions, a lot of causal explanations, which are in fact a lot of hypotheses, and they are arranged in a framework, in a specific structure, okay? And it is something that for the consequence has a lot of mechanisms that may be grouped, arranged, organized to explain some phenomena. And they also provide this important information that is a particular domain, which is basically the species, the systems of the group of species for which the theory may be able to explain the phenomena, okay? I also find some discussions about the purpose of the theory. And I found this one that I like it a lot, that in which the authors stated that the purpose of a theory is to provide a set of linkages for observations in lower level models or theory of those observations. So a theory is basically something that is much more general than the hypothesis. It often contains a lot of different processes that were evaluated many times and was not rejected, okay? Therefore, they received empirical support. And they are arranged in many different ways to explain things that we want to explain. So if I could draw a theory, I imagine that a theory should be something like this, but bigger, that may contain processes inside it. For example, this theory may contain process A, which is related, which is part of this theory. It could be related to another process, which is process C, for example, and is highly related to A. It could have another process that is major than the others, is greater. It could have another less related processes, but they may be linked somehow. It may contain smaller processes that are only partially related to the theory, okay? So it is an arrangement of many different processes. Instead, some processes may contain smaller processes inside them, okay? So this is the way I often see the theory, and my hypothesis is often located in some part of it. It is linked to the theory in some point, okay? For example, today, when I was starting this course, I provided this hypothesis for you, that males are signaling their condition to improve their mating chances. But why I choose this hypothesis? What were the basis of this hypothesis? So I actually used a theory to do this. I was basing this hypothesis on the theory of sexual selection. And basically, sexual selection tried to explain the evolution of traits that increase the chance to find, acquire, and select mating partners. And I may also define a domain for this. Every species that have sexual reproduction I may use the theory of sexual selection to explain some phenomena, some patterns in species with sexual reproduction, okay? But sexual selection contains a lot of many different processes, a lot of different mechanisms. And one in particular interested me to make this hypothesis, which was mate choice. So mate choice, it is a smaller process inside sexual selection, and it states that individuals of one sex that may achieve high reproductive success if they are able to choose partners that provide greater benefits. So if individuals that choose specific partners increase their mating success, this behavior, which is mate choice, may be favored, okay? And mate choice is related to the existence or evolution of male cues, because in many species, males that possess cues that are honest signals to females that these males are partners in better condition, high quality partners, these cues should be favored, okay? So by using this structure, I derived that hypothesis. So it was linked to this theory, okay? And I think that one of the most important part here is how can I translate both the theory and the fantastic four into an introduction, okay? Because I have to arrange, to mix all the things to write an introduction. This, I would like to remember one of the definitions of science that I have shown to you yesterday, which is this one provided by Edward Wilson, which is the organized systematic enterprise that gathers knowledge about the world and condenses the knowledge into testable laws and principles, okay? I would like to highlight this part. The science should condense the knowledge into testable laws and principles. So if I think about the theory and I want to condense the knowledge into testable laws and principles, basically I would create a hypothesis inside this theory, and we use some processes presented in this theory to build my hypothesis, to provide assumptions to my hypothesis, okay? So I have a hierarchical structure here. The theory is greater, the process is smaller inside the theory, and finally I get the hypothesis. So when I'm thinking about an introduction, I have to show to the reader that there is a connection from the theory to the processes and how they are arranged to provide, to create a given hypothesis, okay? I think that this is not a surprise for many of you, but if I could draw again an introduction, I really like to draw things, but introduction is often referred to as an inverted triangle, okay? So when we are writing our introduction, we should begin by the more general aspect of it, which is more linked to the theory, and we should finish the introduction with the more specific aspect of it, which is the hypothesis, and if possible, because this is not always possible, show the predictions. And inside this, I have what is called the contextualization. Oh, I cannot say this in English, sorry. Basically, I have to show what were my rationale, how I took some specific parts of this general theory, arranged them in causal relationships that leaded the reader to understand why I thought about a given hypothesis. This is the same thing as imagine that your hypothesis should be the core of your introduction. So every single paragraph along your introduction should be somehow related to your hypothesis. If the reader is able to imagine your hypothesis before reading it, this is a good cue that you are able to write a clear hypothesis, okay? To make this more concrete, I just took, again, an article from in Animal Behavior, this one from 2010, that I really like the way that these authors structured their introduction, okay? So in this article, they were interested in evaluating leaf-cutting ants behavior, specifically these species, Atacephalotes, which are very common in the tropics, okay? In this species, the workers, they cut leaves from many different trees. They take these leaves to the nest, and these leaves is used as a substrate for fungus that will grow upon these leaves, and the ants just ate the reproductive body of this fungus, okay? So to collect these leaves, these ants make these trails, and they use it for many times to go to the tree, to the plant they are cutting the leaves, and to take it back to the nest, okay? And when they are carrying the leaves here, there is a specific dynamics that may be adopted. And the authors were interested in evaluating these dynamics, okay? So they structured their introduction into 4 paragraphs. They started by discussing potential benefits that should be acquired with information transfer between individuals in social species. So note that they restricted their first paragraph to social species, okay? They were not so general, but this is not a problem, actually. And they discussed potential benefits, particular fitness benefits. So they use as a basis natural selection here. After this, in the second paragraph, they discussed possible costs of group living, which is highly connected to social species, and they emphasized possible costs that individuals may incur in forage trails. They did not restrict it to leaf-cutting ants, but to ants in general, because in many species they do such trails, okay? So this is more restricted in relation to this one. After this, they explained how is the dynamics of individual locomotion, specifically in trails of leaf-cutting ants, because in this part, they describe that when individuals are walking in these trails, they perform these head-on encounters, head-to-head encounters between individuals that are leaving the nest, individuals that are arriving in the nest, and they discussed their effect on the net speed of individuals in these trails. In this point, they provided the fact in the questions, okay? The fact they provided was that head-on encounters reduced the net speed by around 20% relative to free flow velocities, and they had another article to support this fact, and they explicitly presented the question, which was this one, which behaviors might reduce this cost, okay? And in the fourth paragraph, they basically presented their hypotheses and predictions, and they presented 3 different hypotheses. So they imagined that the head-ons occur because it provides information transfer, and they imagined that the information transferred from latent to unladen workers was concerned to trade conditions, to orientation cues, and to food location, basically. And then they presented 1 predictions to each possibility here. So I decided just to draw, so you can see this. For example, for trade conditions, they stated that the number of head-on encounters, which was the dependent variable, should change if the trail had received a disturbance or not. Basically, they did a before and after experiment. So they quantified the number of head-ons before trade disturbance, and they imagined, they predicted actually that the number should increase after the trade disturbance, okay? For the second one, they imagined that the time that an individual would lose to get a proper orientation to the food should be related to the number of head-on encounters or height of head-on encounters. They imagined that the higher the height of head-on encounters, the faster the individual would find a proper orientation to the plant. So they imagine that this relationship should occur, okay? The time lost until proper orientation should reduce when individual perform much head encounters. And for the third one, they imagine that the probability to find food by each individual should be related to the number of head-on encounters. So again, they quantify the number of head-on encounters to each individual, and they imagine that the higher the number of head-on encounters will be related to a higher probability of finding food. They also expected this situation. So they built the introduction, this inverted triangle structure, and at the final, they presented both the hypotheses and the predictions they would expect for this study. Actually presented it in a table, okay, which is not so common, but was very informative. I think that I just finished my presentation. Let me see. Yes, I would just want to make some acknowledgements in the end, because I would like to thank very much Lilian, Monica, and Esteban for the invitation to be here to talk with you about this subject that I like so much. And also I'd like to thank the Animal Behavior Society for the opportunity to be here. And I would also like to thank these two researchers, these two Brazilian researchers actually, which are Glauco Machado and Paulo de Marco Jr., because they taught me most of the things that I presented to you yesterday and today. I learned most of those things from them. I'm very thankful to both of them. And to all of you that had the patience to remain until this time here in this workshop. Thank you very much. And if you have any more questions, just post it on the chat, please. Let me see. Keep here. Okay. Billy Groom is asking if is it possible to submit an experiment study if one is not on academia? Bill, I don't know. Some years ago, I had a co-author that was not on academia, and he was able to participate in the article and to publish the article. I had to explain the editor that he was not working in any university, okay? But specifically for the pre-registration registered report, I do not know if this is possible because I did not try to do this, okay? Sorry. Okay, great. Oh, thank you. Okay, Mark, I can send you the PowerPoint, okay? I can make it in a PDF format, which is smaller, and just email me asking for this and I can send it to you because it is not available in any platform, okay? You're welcome. I'm very happy that you liked this workshop. Okay. Some thanks in Portuguese. De nada. Okay, people. Thank you very much. I'm very glad that you liked this workshop. I was very nervous because this was my first international workshop. So I'm very, very glad that you enjoyed it. And if you have any criticism about this workshop, please, you can also email me and send suggestions and things like this, because I would really like to see it too, okay? So if we don't have any question, and our time is up actually, I will finish it, and thank you again for showing up in this workshop, okay? I really like to present it to you. Oh, Pedro, my mail was my presentation, but I'll put it here. Here. Oh, sorry, I did not send to the general. Here's my email here.